Good morning. My name is Professor Manish Kumar Singhal. I am associate professor in AIML branch, and my subject name is Natural Language Processing. And today I am here to give a video lecture on the topic is context-free grammar (CFG). That is the topic in Unit 4. So let's start. Context-free grammar is a normal and a formal system used in NLP to model the syntactic structure of sentences. It provides a set of rules for breaking sentences down into their constituent parts like noun phrases and verb phrases, forming the basis for parsing human language. Core components. A CFG is formally defined by four elements, that is variable, terminal, production, and system. Variable also called non-terminal symbols. Abstract syntactic categories or placeholders that represents phrases or clauses as implies as for sentences, NP for noun phrases, VP for verb phrases. Terminal symbols, the actual words or tokens that appear in the final sentence and cannot be broken down further. Likewise, the cat chases. Production rules, it denoted by P. Rules that specify how non-terminal symbols can be replaced by sequences of other non-terminals and terminals. Likewise, the rules S tends to NPVP means a sentence can be a noun phrase followed by a verb phrase. Starting symbol, that is denoted by S, a designated non-terminal from which all valid sentences in the language are derived. Role in NLP. Context free grammar are primarily used in the syntactic analysis or parsing phase of NLP. What is parsing? The process of analyzing a sequence of words to determine its grammatical structure according to the CFG's rules. This structure is often represented as a parse tree, which shows the hierarchical relationship between words and phrases. Applications. Context free grammar serve as a foundational concept in various NLP domains, including grammar checkers, machine translations, question answering systems. Grammar checkers. NLP based grammar checkers use techniques like syntax based parsing, statistical algorithms, and deep learning to identify and correct errors in text. These tools analyze sentences structure and compare it to linguistic patterns to flag issues like incorrect verb agreement or punctuation. And modern checkers use deep learning models to provide more contextually aware suggestions. Machine translations in NLP is the process of using computer software to automatically translate text or speech from a source language to a target language, preserving the original meaning and context. For example of empty models and techniques, rule-based translations, statistical machine translations, neural machines translation. It is also called NMT. Question answering systems. Question answering systems in NLP are applications that provide specific answers to questions asked in natural language rather than just returning a list of documents. Types of question answering system: open domain system and closed domain system. What is open domain system? Open domain system can answer questions about nearly any topic, typically using the entire web or massive collection of diverse documents as their source. What about closed domain systems? They are the limited to specific topics. It implies medical information, company FAQs, and can achieve higher accuracy within their narrow scope. Speech recognition. Speech recognition and NLP work together by first converting spoken language to text and then processing that text to understanding its meaning and intent. the speech recognition component known as automatic speech recognition ASR. Real world applications. The integration of speech recognition and NLP powers numerous everyday applications. Virtual assistants, in that form, Siri, Alexa, and Google Assistants. Transcription services, automatic transcriptions of meetings, lectures, and medical notes in healthcare. Accessibility tools, providing hands free operations for people with disabilities or generating real time closed captions. Customer services, powering intelligent chatbots and automated phone systems in call centers. Limitations. The CFG limitations have when dealing with the full complexity of natural language despite being powerful for capturing the hierarchical structure of language, ambiguity, a single sentence may have multiple valid parse tree, which can lead to different interpretations. An example is I saw the man with the telescope, which could mean the speaker used a telescope or the man had a telescope. Context sensitivity. Pure CFGs struggle to capture phenomena that depend on surrounding context outside the immediate phrase structure. For example, a subject verb agreement. It implies distinguishing between the dog runs and the dogs run. Limited expressiveness. Certain complex linguistic phenomena like idiomatic expressions and long distance dependencies are not handled well. Thank you so much. Thank you for watching the video.